Here we have a calculus problem on finding critical numbers of a function. So there is a function given over here that is f of x equals to x positive sin x, and we have to find critical numbers for this function in the closed interval 0, 2 pi. Okay, when I want to find critical numbers for a function, what I have to do is I have to get the first derivative of the given function, and then it has to be equated to 0 and solve for x. So when I equate the first derivative to 0 and solve for x, so the values which I get for x will represent the critical numbers for the given function. Okay, let me write the given function as it is, that is f of x equals to x positive sin x. Okay, now let me find the first derivative of this function, that is f prime of x equals to, when I find the derivative of this x, I'm just getting 1. The derivative of this sin x is cosine x. Okay, now I got the first derivative. Now what I need to do is I have to equate this first derivative to 0. Okay, then I'm getting 1 positive cosine x equals to 0. Okay, now let me subtract 1 from both sides. When I do so, this positive and negative 1 will cancel out. I am getting cosine x equals to negative 1. Okay, now in this equation, I have to solve for x. Okay, for that, we have to find the angle measure that we have for x, so that the value of cosine is negative 1. So now for that we have to consider the quadrants, 4 quadrants. Okay, now let me draw over. Here we have 4 quadrants. So this is quadrant 1 and quadrant 2, and this is quadrant 3, and this is quadrant 4. And here we have 0 angle, and here we have pi over 2 radians. Here we have pi radians, and here we have 3 pi over 2 radians. So here we have 2 pi. So we have 2 pi at the same place of 0. Okay, now let's consider the value of cosine at these 4 corners. So here at this portion, the value of cosine is what? So that is cosine 0 equals to 1. So, and also for 2 pi also, the value of cosine is 1. So at this portion, so the value of the cosine will take the value 1. Okay, now let's consider this portion. So that is the value of cosine pi over 2 equals to 0. At this portion, the value of cosine is 0. That is cosine 3 pi over 2 equals to 0. At this portion, what's the value of cosine? It is equal to negative 1. That is cosine pi equals to negative 1. So from 0 to 2 pi, so the cosine gets the value negative 1 only at this portion. That is when the angle measure is pi radians. So when cosine x equals to negative 1, then the angle measure x must be pi radians. So when I plug in pi for x over here, the value of cosine equals to negative 1. So there is only one value from 0 to 2 pi, so for which the value of cosine is negative 1. So we got value for x pi by equating the first derivative to 0. So this value is called critical number. And here we have a question. Is there only one critical number pi for the given function? So always we have to do one more check. Once we get the value of x by equating the first derivative to 0, we have to do one more check with the result of the first derivative. Okay, now in the result of the first derivative, what I need to do is I have to check it whether is there any real value for x for which the first derivative becomes undefined. Actually, cosine x will never become undefined, because the minimum value of cosine is negative 1. That is negative 1 less than or equal to cosine theta less than or equal to positive 1. So the minimum value of cosine is negative 1 and the maximum value of cosine is positive 1. So it will never become undefined. So always the value of cosine will oscillate from negative 1 to positive 1. So if I plug in any real value for x over here as an angle measure, so cosine x will oscillate from negative 1 to positive 1. It will never become undefined. So in this case, this first derivative, I mean f prime of x, will never become undefined for any real value of x. And here we have a question. In case there is a real value for x for which the first derivative f prime of x becomes undefined, what do we have to do? If there is any real value of x for which f prime of x becomes undefined, then that real value of x also should be considered as critical number. So the value, the real value of x which makes f prime of x undefined should be considered as critical number. But in this problem, so no real value of x will make this f prime of x undefined. So we don't get any critical number in this check. So we have to consider only this pi as a critical number for the given function in the closed interval 0, 2 pi.